Imagine you have three servers. You assign requests using hash mod 3, simple and fast. Then traffic spikes and you add a fourth server. Hash mod 4 gives completely different results. Every cached item points to the wrong server. Cache hit rate craters. Databases get hammered. This cascading failure is the rehashing nightmare, and it's exactly what consistent hashing was designed to prevent. The math makes the problem undeniable. With n servers and server equals hash mod n, adding just one server reshuffles roughly 75% of all keys. That's a thundering herd. 75% of requests simultaneously missing cache and hammering your database. Facebook saw cascading cache invalidation contribute to a major outage. You can't engineer your way around this with mod-based hashing. You need a different model entirely. Consistent hashing uses a ring, a circular space from 0 to 2 to the 32nd power. Servers and keys both get hashed onto this ring. To find a keys server, walk clockwise until you hit one. Add a new server and it only takes keys from its clockwise neighbor, about 1 over n of all keys. Remove a server and only its keys move. The rest of the ring is completely undisturbed. That's the breakthrough. The math is elegant. MurmurHash maps any input to a 32-bit integer over 4 billion ring positions. Servers are placed by hashing their IP and port. Keys are placed by hashing the request identifier. Lookup is a sorted set ceiling query, O of log n. So is insertion and deletion. The whole structure takes O of n space. Compare that to modern hashing, which requires touching nearly every key on a cluster change. When a server fails on the hash ring, only the keys between it and its counterclockwise neighbor need to move clockwise to the next alive server. With 100 servers, one failure moves about 1% of keys. You can add replication by assigning each key to the next key servers clockwise. If one fails, the next replica already has the data. Failure becomes a local, bounded event, not a global crisis. Hashing server IDs directly gives random placement. One server might own 40% of the ring. Virtual nodes fix this. Each physical server gets 150 to 250 virtual identities scattered around the ring. By the law of large numbers, load evens out automatically. Apache Cassandra uses 256 virtual nodes per physical node by default. Amazon DynamoDB calls them token ranges. More vnodes means finer, more even distribution. Virtual nodes solve load imbalance but not hotspots. A viral post sends millions of requests to one single key, one server. The solution is scatter-gather. Append a random suffix to the hotkey, scatter variants across multiple servers, and aggregate on read. DynamoDB detects hot partitions automatically via adaptive capacity and splits them. Google Bigtable uses range splits. The principle: detect, split, redistribute transparently. Rendezvous hashing is an alternative invented the same year, 1997. Each client scores every server by hashing the key with each server's ID. Highest score wins. It gives perfectly uniform distribution with no virtual nodes needed. The trade-off: O of n lookup. You must score every server. For small clusters, rendezvous hashing is simpler and more elegant. Nginx uses it. For large clusters of thousands, ring-based consistent hashing wins. Consistent hashing is inside the world's largest systems. Apache Cassandra distributes petabytes using token rings. DynamoDB routes queries in single-digit milliseconds. Discord handles 19 billion messages per day with consistent hash sharding. Akamai, the CDN giant, was co-founded by David Karger, one of consistent hashing's inventors, specifically to apply it to web caching. The CHOT DHT protocol built peer-to-peer networking on it. In production, consistent hashing is a sorted map of token to server. Add a server, generate wire tokens, insert them. Lookup, binary search for the ceiling token, wrap around if needed. In Go, Group Cache by Brad Fitzpatrick is a production-ready ring in 100 lines. Redis cluster simplifies this to 16,384 fixed hash slots with gossip propagation. The implementation is always the same idea: minimize disruption, distribute uniformly, handle failure locally. Consistent hashing is elegant and indispensable. A ring, a clockwise walk. Add or remove servers with almost zero disruption. It powers DynamoDB, Cassandra, Akamai, Discord silently at planetary scale. If this clicked for you, subscribe to the Logic Blueprint. Thank you for watching.